Hi everybody. Today we will look at another alternative way to look at and measure correlation between two different variables. In our case, we have returns of asset X and asset Y. Um, Kendall's tau, or also known as Kendall's correlation measure, or Kendall's rank correlation. Similar to Spearman rank correlation, this is another ordinal correlation measure, meaning that the magnitude of each variable does not really matter. The only thing that we care about is the ranks of those variables. In particular, the rank of observation y assigned to the rank of observation x. So we have uh, observations X already ranked from lowest to highest. So during year 2012, asset X had the lowest possible return and asset Y had the fourth lowest return. During 2009, both assets had the third lowest return. And for example, in 2011, asset X had the fifth lowest return, meaning it had the highest return, but asset Y had the second lowest return. So our question is, how do these ranks translate into the correlation or codependence of these two assets over time, these annual returns over time? The formula for Kendall's tau is very simple, but not very straightforward. So it's easier if you watch somebody do it and understand it before you get your computer to calculate it for you, or before you code the computer yourself. So the top means that it's the number of concordant pairs minus the number of discordant pairs divided by the total number of pairs. Before we define what's a concordant pair and what's a discordant pair, we have to define what's a pair and what are we pairing. So to do that, you have to realize that there are 5 observations of ranks. So look at 1 and 4 as one observation as opposed to two different numbers. So each observation consists of an x value and a y value. 1, 4 is one observation, 2, 5 is another observation. So we need to pair each one of these observations with every other observation. So 1, 4 will need to pair with 2, 5, will need to pair with 3, 3, will need to pair with 4, 1. So every observation will need to be paired with every other observation. The total number will be dictated by the number of combinations formula. If you're familiar with it, it's the 5 choose 2. So number of ways to choose 2 observations from 5 possible observations. And that's the same exact formula if you're familiar with combinatorics for this denominator. So for 5 available observations, the denominator will be 10. So we will need to come up with 10 different pairs. Each pair will have 2 sets of x and y values. So let me label my columns x1 and y1. So the first observation will have an x value and a y value. And then we will pair it with another observation that will have its own x value and y value. So I'll label it as x2 and y2. So let's start with the observation of 1, 4 and pair it with the first value of 2, 5. Then we'll take the same observation of 1, 4 and pair it with the observation of 3, 3. 1, 4, 3, 3. By the way, this section right here is independent from the section on the left. So we're merely listing 10 different pairs of observations. They do not correspond to the years you see on the left here. So 1, 4 needs to be paired with 4, 1. 1, 4 needs to be paired with 5, 2. 1, 4, 5, 2. So now we've paired 1, 4 with 4 other observations. Now let's move on to the next observation. Next observation is 2, 5. So 2, 5. 2, 5 was already paired with 1, 4 earlier. And we have this pair right here, so we don't have to pair it again. Now we need to pair 2, 5 with 3, 3. And then 2, 5 with 4, 1. Then 2, 5 with 5, 2. Now we move on to the next one. 3, 3 needs to be paired with 4, 1. 3, 3 again was already paired with 2, 5 and 1, 4 earlier, so we move only down. 3, 3 needs to be paired with 4, 1. 3, 3 with 5, 2. Now 4, 1 needs to be paired with 5, 2. So we have exhausted our available pairs, and based on the formula, I was expecting us to have 10 different pairs. So let's just count them, and indeed we have 10 different pairs that we have come up with. Now we have 10 available pairs. The formula says count those pairs that are concordant and subtract the number of those pairs who are discordant. What's a concordant or discordant pair? So a pair is known as concordant if the y values are both greater than the x values. Or in other words, if y value of this observation is greater than y value of the first observation and x value of this observation is greater than x value of this observation. So you're comparing x to x and y to y. And if the comparison results in the same direction for both x and y, that pair is known as concordant. Otherwise, it will be known as discordant. So let me make it um, a little bit easier by color coding my variables x and y. To make it easier for myself, I will make xy, x is orange and y's I will make green in color. So now I will compare x2 to x1. If x2 is greater than x1, I will make this observation green. And if y2 is greater than y1, in this case it is, I will also make that observation green. So if both these colors are the same, that means that pair is concordant. So I will mark it as a concordant pair. Now, is x2 greater than x1? Yes, it is. I will make it I'll flag it as a green color. Now, is y2 greater than y1? In this case, it's not. y2 is smaller than y1. So I will choose another color. Let's pick red color to make to denote y2 value of greater than 4. So these two colors are different, meaning the x and y comparisons look in different directions. So that's a discordant pair. x2 is greater than x1. So I'll make it as green. y2 is smaller than y1, so I will mark it as red. That's another discordant pair because these two colors are different. Now 5 is greater than 1, that's a green color. 2 is less than 4, that's a red color. That's another, colors are different. I will mark it as discordant. 3 is greater than 2, that's green. 3 is less than 5, that's a red. Again, different colors. That's a discordant pair. 4 is bigger than 2. 1 is less than 5. So that's another discordant pair. Let me color code these numbers. 5 is greater than 2. 2 is less than 5. Another discordant. So this one is discordant. This one is discordant. 4 is greater than 3. 1 is less than 3. That's another discordant pair. 5 is greater than 3. 2 is smaller than 3. That's another discordant pair. A lot of discordant pairs here. Now 5 is greater than 4. That's a green color. And 2 is greater than 1. That's also a green color. So the colors are the same. So that makes that pair a concordant one. So now we have a total of 10 pairs. And we need to count how many of them are concordant. And there are 2 concordant pairs and there are 8 discordant pairs. So with a small sample like this, it's easier to just count the number of concordant and discordant pairs. But if this was a bigger sample, we would need to use a function, and I'll go ahead and use a function count if. So equals count if this range, and only count those values that are equal to C. And it will tell us that there are 2 values of C and there are 8 values of D for a total number of pairs of 10. So let's go back to our formula, the numerator, and let me mark my numerator and my denominator separately, and let me compute them separately. So the numerator is number of concordant pairs minus the number of discordant pairs. We know that there are 2 concordant pairs minus the 8 discordant pairs. My numerator is -6. My denominator is the total number of pairs. We already know that's 5, choose 2, or that's 10, but nevertheless, let me recalculate it. And do we have n? We don't have n anywhere, so let me add n as the number of observations. A number of observations is the count of these, which is 5. So the denominator is 5 times 5 minus 1 divided by 2, which is 10. And now I'm ready to calculate Kendall's tau. Kendall's tau is the numerator divided by the denominator. Kendall's tau is -0.6. For the same data set, if you remember, our Pearson correlation coefficient was -0.74. Our Spearman's rank correlation was -0.8, and our Kendall's tau is -0.6. So they are all negative, meaning that these assets are negatively correlated. When asset X returns a negative rate of return, asset Y tends to exhibit a positive return, and vice versa. And Kendall's tau is smaller in this case in magnitude than both the Spearman and the Pearson correlation measures. And again, Kendall's tau is another ordinal measure. So it is not sensitive to outliers, and it only takes into account the rank of those returns, but not the magnitude of those returns. Thank you for watching, and I hope this was helpful.